And now please welcome to another problem of stoichiometry. As you probably know watching my previous videos of stoichiometry, the action revolves around the chemical equation where we are given a substance and we are asked to calculate another substance. The most favorable situation is when they are giving grams of substance and they are asking us to calculate grams of the product. But how about if the substance is given not in grams but in a dissolution? Or perhaps they're giving us the richness of a mineral. They can also complicate us the way to present the products. For example, if a product is given in the form of a gas. And what happens if the reaction has a yield? Please don't be scared at all. I will show you this typical and very easy situation in all my videos. So please, no more words. Let's get to it.
Binnacle project.
It says that 500 grams of pyrite, which has an iron disulfide content of 85%, this is the situation that I want to show you how to deal with in this problem, is reacted with oxygen to obtain iron 3 oxide and sulfur dioxide. Section A says, calculate the grams of oxygen needed. Section B says, calculate the grams obtained of each product. And Section C says, verify that the Law of Lavoisier law holds true. So let's begin. First of all, let me draw the 500 grams of pyrite for you in order to understand the situation. They are giving us 500 grams of pyrite. Here you have it. 500 grams of pyrite. And they are telling us the content in iron disulfide, and they say that it's 85%. 85% in iron disulfide. What does it mean? It means that this mineral, this 500 grams of pyrite, is not made all by iron disulfide, only the 85%. Here you have it. The 85% is truly iron disulfide. The rest of our mineral is formed by other substances that don't matter at all in our equation. Okay? So now, what are we going to do? We are just calculating 85% of 500, and we have already obtained the grams of iron disulfide for our reaction, for our problem. Let's do it. 85% multiplying 500. So now please take your calculator in order to do 85 divided by 100, or 0.85 multiplying 500, and we have 425 grams of iron disulfide. Iron disulfide. The situation that I wanted to give you through this problem is that instead of giving us directly 425 grams of iron disulfide, they are telling us that it comes in 500 grams of pyrite and only 85% of iron disulfide. So now you already know how to deal with this situation. And now it's time to write the equation. It says that 500 grams of pyrite, which has an iron disulfide content, iron disulfide, is reacted with oxygen gas of course, so it's diatomic, in order to obtain iron 3 oxide, and sulfur dioxide. And now it's time to balance the equation. As I recommended you when balancing equations, if you find a single substance, please leave it for last, in order to avoid that horrible situation that when balancing an atom, another atom gets imbalance. So let's leave oxygens for last. One iron atom on left, two iron atoms on right. So by placing here number 2, we have already iron atoms balanced. Now here you can see that it's formed 4 sulfur atoms on the left. So by placing here number 4, we have already 4 sulfur atoms on right. And now oxygens. 3 oxygens here. 4 times 2 is 8 oxygens here. 3 plus 8 is 11. So how can we achieve 11 oxygen atoms in this position? Just place 11 divided by 2 in order to cancel the effects of this subscript. And that's it. If you don't want to work with this fraction, and if you want to cancel this denominator, just multiply all the equation by 2. And 2 times 2 is 4 iron disulfide, plus 2 times 11 halves is 11 oxygen atoms. 2 times 1 is 2 iron 3 oxide, and 2 times 4 is 8 sulfur dioxide. And this is the reaction we are working with. Don't forget that a few minutes ago we obtained 425 grams of iron disulfide, so section A says calculate the grams of oxygen needed. So we are doing just the typical conversion factors. 425 grams of iron disulfide. And there comes the first conversion factor, which helps us to change from grams of iron disulfide in order to move into moles of iron disulfide. And I tell you that using 1 mole will be enough to do this calculation. Now it's time to add the atomic masses of these atoms. Iron atom is 55.8 plus 2 sulfur atoms, so we are doing 2 times 32, as you can read from the statement. And if you place this substance in these numbers in the calculator, 55.8 plus 2 times 32 is 119.8 grams per mole. Okay? So we are placing here 119.8 grams of iron disulfide is 1 mole of iron disulfide. Is it right? And now there comes the second conversion factor. It helps us to change from moles of iron disulfide to move into moles of oxygen gas. And here we are placing the stoichiometric coefficients, number 4 for iron disulfide and 11 for the oxygen. And of course, naturally, there comes the last conversion factor, which helps us to change from moles of oxygen, and as I told you previously, only with 1 mole will be enough to do this calculation, 1 mole of oxygen gas, to move into grams of oxygen. And now it's time to calculate the atomic mass of this substance. Just 2 oxygen atoms, so we are doing 2 times 16. And it is obviously 32 grams of oxygen. Now it's time to introduce it in the calculator, and we will have already solved the A section. Hope you have obtained 312.18 grams of oxygen will be necessary to make this 425 grams of iron disulfide react. And don't forget what we've done. The new thing in this statement, in this problem, is that this substance is not given directly. We are not told that 425 grams of iron disulfide reacts with blah blah blah. No, it says that this substance comes in a mineral of 500 grams of pyrite, which has a content of 85%. This was the new thing in this problem.
Binnacle project.
As I ran out of space, I've erased the whiteboard, but I've written here the previous calculation. So now section B says, calculate the grams obtained of each product. So now it's time to calculate the grams of iron 3 oxide and sulfur dioxide. Now we are preparing 2 trains, 425 grams of iron disulfide, in order to calculate the grams of iron 3 oxide, and this other train, 425 grams of iron disulfide, in order to calculate the grams of sulfur dioxide. Let's do it. The first calculation is, as usually, grams of iron disulfide to move into moles of iron disulfide. Just 1 mole here, and as in the previous section, 119.8. Now it's time to calculate the second conversion factor, which helps us to move from moles of iron disulfide to move into moles of iron 3 oxide. Iron 3 oxide. And there comes, of course, the conversion factors. Number 4 for iron disulfide and number 2 for iron 3 oxide. The stoichiometry between these two substances is 4:2. And there comes the last conversion factor, which as always helps us to move from moles of iron oxide, 3 oxide, to present the solution in the form of grams of iron oxide, okay? And of course, with only 1 mole will be enough to do this calculation. And now it's time to add 2 iron atoms. So we are doing 2 times 55.8 plus 3 oxygen atoms. So we are doing 3 times 16. Let's use the calculator, and we are knowing the mass of 1 mole of iron 3 oxide. 2 times 55.8 plus 3 times 16, which is 159.6 grams of iron 3 oxide. And of course, we are doing the same with this other substance. We're beginning with our 425 grams of iron disulfide, and we are multiplying by the first conversion factor, which serves to change from grams of iron disulfide and to move into moles of iron disulfide. And it's the same. 1 mole of iron disulfide is 119.8 grams of iron disulfide. And there comes the second conversion factor. We are changing from moles of iron disulfide to get into moles of sulfur dioxide. And there comes, of course, the stoichiometric coefficients, number 4 for iron disulfide and number 8 for sulfur dioxide. And finally, our last conversion factor helps us to move from moles of sulfur dioxide, and only with 1 mole will be enough to do this calculation. Here 1 mole, and also here 1 mole. Now it's time to move into grams of sulfur dioxide. And now it's time, as always, to add the atomic masses of these atoms. Sulfur atom, 32, plus 2 oxygen atoms, so 2 times 16. Let's write it in the calculator. 32 plus 2 times 16. And it is 64 grams of sulfur dioxide. If you have in your hand 64 grams of sulfur dioxide, you have 1 mole of that substance. And now, by introducing it in the calculator, we have 425 multiplying 8 multiplying 64 and divided by 119.8 multiplying 4. We have 454.1 grams of sulfur dioxide will be formed. And that's all.
Binnacle Project.
And now it's time to verify that Lavoisier's law holds true, which means to just let's add the grams we have obtained in reagents, which means to do 425. Let's use our calculator to do 425 plus 312.18. It gives us 737.18 grams in reagents. And we are, of course, also doing the same in products. So let's do 283.1 plus 454.1, and it gives us 737.2 grams in products. So as you can see, this is not a coincidence. This is Lavoisier's law. I hope you've enjoyed doing this exercise with me, and on this occasion I wanted to confront you to the possibility of having to deal with a problem in which, instead of giving us directly grams of a substance, They are hidden in the form of a rock or a mineral from which we are given the content or the richness in certain substance. But as you can see, it's very, very easy. But I'm afraid that there are still several situations that we have to consider when doing an stoichiometry problem, and we will study them in the following videos. So, see you next time! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!